We just talked about computing the number of shared pairs in a Lewis structure. That is recommended before ever putting pencil to paper to draw a structure. Once we know how many shared pairs should be added, arrange the atoms on your drawing board. For many of the simple molecules we draw here, there is a central atom surrounded by terminal atoms. For that type of molecule, the central atom is almost always the most positive, or least electronegative, atom present. An exception would, of course, be hydrogen. Hydrogen only ever wants one shared pair, so it can never be in the middle. The least electronegative atom is usually written first in the formula, so that is also a clue. Once atoms are arranged, add the shared pairs. Then finally, add in lone pairs on all the atoms, central and terminal, to complete octets. Let's do a couple of examples to see how this works. First, dinitrogen. We did this before, but let's see how it works with this new procedure. In a previous video, we determined sp. Er is 16, as each nitrogen atom wants 8 electrons. Each only has 5, so Ve is 10. There is a deficit of 6 electrons, so there will be 3 shared pairs. We start by drawing the two N atoms side by side. Then, the 3 shared pairs are added as 3 lines. Remember that each line represents 2 electrons. With the 3 shared pairs, each atom feels 6 electrons. To get to the octets, we need to add 1 lone pair to each nitrogen. Notice that the 6 electrons in the triple bond plus the 4 electrons in the lone pairs total to 10, which is Ve in the formula. Let's try ammonia, NH3. Nitrogen wants 8 electrons and each hydrogen wants 2, so Er is 14 for this molecule. Nitrogen brings 5 valence electrons and each hydrogen brings 1, so Ve is 8. This is again a deficit of 6 electrons or 3 shared pairs. Once we have sp in hand, we lay out the atoms with nitrogen in the middle and the 3 hydrogens around the outside. We have 3 shared pairs to add, so we draw 1 to each hydrogen. Finally, we ensure that we have octets at every atom. Hydrogen atoms only want 2 electrons, and that is fulfilled by the single bonds. 3 single bonds is 6 electrons, so a lone pair needs to be added to the central nitrogen. You should work through the examples on the next page of the module to practice this method. Being able to draw Lewis structures is essential for extracting information about the molecule.